So the first question which I am going to take up is a very common question given in all books, and you need to be well aware of this question. 7 years ago, a person Vivek was 5 times the square of Seema's age. So the condition is given based on the ages 7 years ago. And what about the second condition? After 3 years. So from now, after 3 years, Seema will be 2/5 of Vivek's age. So we need to find the present ages. The thing to note here is that we need to find the percentages, and the conditions which are given are not based on the percentages. The conditions are given 7 years ago and 3 years later. So we need to assume the ages of Vivek and Seema 7 years ago. Now Vivek was 5 times the square of Seema's age. So we can find Vivek's age only when we know Seema's age. So let us assume that Seema's age 7 years ago was X years. So therefore, we can find Vivek's age 7 years ago. How? Vivek was means equal to 5 times the square of Seema's age. Seema's age is X, so the square of X. So 5 times the square of Seema's age. So these many years. Now these are the ages 7 years ago. So what about the present ages? That implies present age of Seema will be, add 7 to this, these many years. And what about the present age of Vivek? Add 7 to this, you get 5x square plus 7 years. So these are the present ages. And now we can formulate the equation based on the second statement. After 3 years, so another 3 more years to be added to these two. So after 3 years, now I'll write the equation. Seema will be, now Seema's present age is x plus 7. So after 3 years, Seema will be, Seema's age is this, x plus 7 plus 3, will be means equal to 2/5. 2/5 means 2 by 5, of means multiply, Vivek's age. Now Vivek's age, present age is 5x square plus 7. So after 3 years, he will also be 3 years older. So this is the equation which we have to solve to get to the answer. And I'm sure if you know the formulation of the equation, the rest of the things will be very, very easy for you. Now let's cross multiply this. 5x plus 10 equal to 2, 5x square plus 10. So just open the brackets. 5x plus 50 will be equal to 10x square plus 20. Thereby you get the equation 10x square. So 5x goes that side, minus 5x, and 20 minus 50 is minus 30, equal to 0. Now you can see the entire equation is divisible by 5. So you can strike off the common factor 5 from this, thereby getting 2x square minus x minus 6 equal to 0. Now this is the quadratic equation which we need to solve to find the present ages. Let's solve this one now. So I am writing here. Now middle term splitting, 2x square. Now I need two factors whose product is minus 12 and sum is minus 1. Very easy, minus 4 and 3. So minus 4x plus 3x minus 6 equal to 0. So I have split the middle term and now take common. 2x is common, x minus 2 plus 3 is common, x minus 2 equal to 0. And here we have the two factors. X minus 2 is one of the factors and 2x plus 3 is the other factor. Thereby giving you x equal to minus 2 becomes plus 2 and x equal to minus 3 by 2. Now see, minus 3 by 2, it's negative, and we assumed x to be Seema's age 7 years ago. So no one's age can be negative. So this value has to be rejected for obvious reasons. And now we have x equal to 2. And once we get to the value of x equal to 2, just substitute the value of x here. You will get the present ages of both persons. Therefore, present age of Seema is equal to x plus 7. X is 2. So 2 plus 7, 9 years. And present age of Vivek, 5x square plus 7. So 5 into 2 square plus 7. 2 square is 4. 4 into 5, 20. 20 plus 7 is 27 years. So the answer for the question, Seema's present age is 9 years and Vivek's present age is 27 years. Students, a very important question, and you cannot just let go this question and appear in your CBSE exams. So prepare well for this question, and let's now come to the second question. In this question, it is given, if Ram was 5 years younger than his real age, means whatever is his age right now, if he was 5 years less than that age, then the square of his age would have been 11 more than 5 times his actual age. Now we need to find the actual age of Ram. So we need to assume that the present age of Ram is x years. So let us assume the present or the actual age of Ram to be x years. Now see, condition is given that if he was 5 years younger, that means 5 years less in age. So according to question, if he was 5 years younger means x minus 5. Now let's read the question from here. The square of his age, that means x minus 5 whole square, would have been, means equal to 11 more, means plus 11, than what? 5 times his actual age. So 5 times his actual age means present age, that is x. So very easy formulation of question, but first time when you read this question, you will feel as if this is slightly difficult. But giving it a second thought and attempting the question will enable you to solve it very easily. So x minus 5 whole square equal to 5x plus 11. Now we will solve this. First of all, open the square. X square minus 10x plus 25. I have applied a minus b whole square identity equal to 5x plus 11. So we have the quadratic equation x square minus 10 minus 5 is minus 15 and 25 minus 11 is 14 equal to 0. Very simple quadratic equation which can be very easily split into factors. So two numbers whose sum is minus 15 and product is 14, minus 14 minus 1. So minus 14x minus x plus 14 equal to 0. Take common x minus 14 minus 1 x minus 14 equal to 0, giving you two factors x minus 1 and x minus 14. And you get x equal to 1 and x equal to 14. Now, in this case, the present age is either 1 year or 14 years. See, if the present age is 1 year, then if Ram was 5 years younger, this condition wouldn't have existed. So we have to reject this x equal to 1, and therefore the present age of Ram is 14 years. Present age of Ram is equal to 14 years. The question goes like this. Two taps running together can fill a tank in 3 1 by 13 hours. So when they are open together, they fill a tank in this much time. Now, comparison of the time taken by them separately is given. If one tap takes 3 hours more than the other tap to fill the tank, then find the time taken by each to fill the tank separately. So we need to find the time taken by the two taps separately to fill the tank. Now in such a question, we need to use only one variable and we need to assume that the time taken by the faster pipe or the pipe of larger diameter is x hours. So let time taken by first pipe be x hours and therefore time taken by second pipe. Now comparative time is given. One tap takes 3 hours more than the other. So if first pipe is consuming x hours, then the other one is consuming 3 hours more. So x plus 3 hours. Now after having assumed the time taken by the two pipes, we need to convert these times into 1 hour work done by the pipes separately. Implies, now what statement do we write in such a question? We need to write the portion of tank filled by first pipe in 1 hour. Portion of tank filled by the first pipe in 1 hour. So if the first pipe is taking x hours, then portion of tank filled by it in 1 hour is 1 upon x. Like if a tank is being filled by a tank in 4 hours, then only 1/4 is filled in 1 hour. So you have to take the reciprocal of this time in order to find this portion of tank filled by the first pipe. Likewise, and similarly portion of tank filled by the second pipe in 1 hour will be 1 upon, now this is x plus 3, so 1 upon x plus 3. And now to formulate the equation, we need to use the first statement here. What is the first statement? The first statement is when they are running together, that means this much work is done in 1 hour by them together, the sum of these two. Then the total time taken is 3 1 by 13 hours. So when we have taken the reciprocal of these two, just add the reciprocals, that is 1 by x and 1 by x plus 3, and this is actually one hour work of both the pipes together. So total time is 3 1 by 13 hours, and 3 1 by 13 is actually 13 3 is 39 plus 1 40 by 13. So if you have taken the reciprocals of these times, then this time is also to be reciprocated in the equation. So don't take 14 by 13, that's a big mistake if you are doing that. 40 by 13 is to be converted into its reciprocal when you put it here in the equation. So this will become 13 upon 40. So very important step, and if you get this equation right, then it's all about solving this by taking LCM. So now you can solve it using the LCM. X and x plus 3, both factors will come in the LCM, and in the numerator x plus 3 plus x, 13 by 40. So this is 2x plus 3 multiplied by 40 equal to 13x x plus 3. So this will get converted into a quadratic equation, 80x plus 120 equal to 13x square plus 39x, thereby giving you a quadratic equation, 13x square, 39 minus 80 is minus 41x, and this goes that side, becomes minus 120 equal to 0. So you see we have formulated a quadratic equation, and this quadratic equation is now to be factorized. I'll tell you the factors which will be used here. It is 65 and 24. So we split the middle term. 65 and 24. So this becomes 13x square minus 65x plus 24x and minus 120. Now it's all about taking common and factorizing. 13x x minus 5 plus 24 x minus 5. So we have x minus 5 in both the brackets, which becomes the first factor, and the second factor 13x plus 24. This gives you x equal to 5 and x equal to something negative. So negative is to be rejected. Why? Because x is the time taken and time taken cannot be negative. So we have x equal to 5. And what was x? It was the time taken by the first pipe. So first pipe takes 5 hours and consequently second pipe takes 3 hours more. So that is 5 plus 3, 8 hours. So this is the answer of this important questions or question of time taken by a pipe to fill a tank. So if you have understood this, now we will be able to solve this one very easily because this is similar to this. So just for practice sake, I have given you one more question here. So let's see the similar thing. So I'll write it in short here. So first pipe, if you assume that first pipe is taking x hours, then the second pipe, see the comparative time, the bigger pipe takes 8 hours less. So x minus 8 hours. So here you have the time taken by the two pipes, which is given as a comparative measure in the question. And now again portion of tank filled by first pipe in 1 hour is again 1 upon x, and similar to this portion of tank filled by second pipe in 1 hour is 1 upon x minus 8. And now you have to add them and equate it to the reciprocal of the total time given. The total time given here is 9 hours 36 minutes. So 9 hours and 36 minutes means 36 upon 60 hours. So you cancel this by 12, 12 3s are 36, 12 5s are 60. So 9 3 by 5. 9 3 by 5 is actually 45, 48 by 5. So take the reciprocal here, 5 by 48. And now take the LCM just as the previous question. X and x minus 8, both factors will come in the denominator, thereby giving you x minus 8 and plus x in the numerator, equated to 5 by 48. Cross multiply 48 by 2x minus 8 and 5x by x minus 8. You get 96x minus 8 is 64, 6, 8 4 is 32 and 6 38, 384 equal to 5x square minus 40x. So here you have the required quadratic equation. 5x square minus 40 and minus 96 is minus 136 x, and this minus 384 goes this side and becomes plus 384. So friends, again a quadratic equation which has been obtained here in this question. Now students, if this question comes in exam and you formulate this kind of equation, then obviously it is little bit difficult in exam to find out the exact factors of such a large quadratic equation. So in such questions, what you need to do is to apply the quadratic formula, which will help you in solving this quite easily. And I'm sure if you use quadratic formula, it will be far easier than the traditional method. So use quadratic formula in this. I'll just tell you the answer which you have to obtain so that you can practice this and feel comfortable in solving questions of this kind in examination. So I'll just tell you the answer for this. The answer for this will come out to be, one of them will be 24. So you can try with 24 means you should get 24 into 5, 120 as first factor. So let me try and solve it for you. Here, the factors which I am taking are 120 and 16. Consequently, you can take common. I'll put a line here just for your convenience. 5x square. So 5x is common, x minus 24, and then minus 16 is common, x minus 24 equal to 0. So 5x minus 16 and x minus 24. So x comes out to be 24 and x comes out to be 16 upon 5. Now see, 16 upon 5 has to be rejected for the simple reason that if x is 16 upon 5, which is 3.2, then x minus 8 will go in negative. So there is no negative time, so this is rejected, thereby giving you the answer that first pipe takes 24 hours to fill the tank, and consequently second pipe takes 8 hours less. So 24 minus 8, 16 hours as the answer of this important question. The question goes like this. The sum of areas of two squares is 640 meters square and the difference of their perimeters is 64 meters. So you need to find the sides of the two squares. So let's see how this is done. Let side of larger square be, say you assume that as x meters, and side of smaller square assume it as y meters. Now first of all I'll consider the first equation as the difference of their perimeters. Now difference of perimeters is given as 64 meters and the other one is sum of areas is 640 meters square. Now let us put the formulas for perimeters and areas. Perimeter 4 into side. So larger square has larger perimeter. So I'll write that first. 4 into side minus difference means minus 4 into y, that is the perimeter of the second square, and this is given as 64. And from this equation you can see that 4 is the common factor throughout. So you can cut that 4, which will give you x minus y equal to 16. And sum of areas, what is the area of a square? Area of a square is side into side, that is side square. So I will write the area which is greater first. So larger square is x meters long, side is x meters. So this area is x square and sum means plus smaller square y square equal to 640. And now all you will have to do is to eliminate one of the variables, either x or y, and put it in this equation. So I'll take the value of x from here, this is y plus 16, and substitute it here. So this equation becomes y plus 16 whole square plus y square equal to 640. And now you can solve this using the traditional method. This will give you y square plus 32y plus 256 plus y square equal to 640. So this equation will be 2y square plus 32y and 256 minus 640. So you need to subtract 640 and 256. This will be 483. So 384, which will be negative. So you can strike up the common factor 2 from here. y square plus 16y minus 192 equal to 0. Now see, this is a quadratic equation, y square plus 16y minus 192 equal to 0. And the middle term split of this equation, okay, we need two numbers whose sum is 16 and product is 192. So 8 4s are 32. Okay, this is 24 and 8. So let's split the middle term, y square plus 24y minus 8y, and after this it is the traditional factorization method. So you have two answers here, y plus 24 and y minus 8 equal to 0. Now students, y plus 24 equal to 0 gives you a negative answer, but side of square cannot be negative. So we will retain only the positive value, y equal to 8. Put y equal to 8 here, x comes out to be 8 plus 16, that is 24 meters. So we have the answer, therefore side of first square is 24 meters and side of second square is 8 meters. So this is the answer which was required in this question. Let's see one more question of quadratic equations. Again a previous year question. 300 apples are distributed equally among a certain number of students. Had there been 10 more students, so obviously if the number of students increase, then each student will get less number of apples. So each would have got one apple less. So you need to find the original number of students. So for this question also we will assume, let the number of students be x. Now total apples is 300. Therefore each student gets 300 upon x, these many apples. But if number of students increases to 10 more, so number of students now becomes x plus 10. So each gets 300 total apples divided by number of students x plus 10. Now which one of these two is more, 300 upon x or 300 upon x plus 10? Here the number of students has increased, so each gets less number of apples. So this is less and this is more. Difference between these two is 1 apple. So according to question, we have difference between these two, 300 upon x and 300 upon x plus 10. The difference is 1 apple, and all you need to do is to take LCM and solve this for getting the value of x now. So let's take the LCM. X and x plus 10 both factors will be there in the LCM, and 300 is common in the numerator. So 1 into x plus 10 is x plus 10 minus 1 into x is x equal to 1. So x gets cancelled. Cross multiply, you get x square plus 10x equal to, this is 300 into 10, that is 3000. And bring this here, you get the quadratic equation, x square plus 10x minus 3000 equal to 0. And we can split the middle term now. Very easy, 60 and 50. So x square plus 60 minus 50 minus 3000 equal to 0, which gives us x plus 60 in the brackets and x minus 50 outside the bracket. So number of students cannot be negative, so we will get only one answer here. x is minus 60. This is to be rejected because number of students is never negative. Gives x equal to 50. So your answer for the question, number of students is 50. A very general question of quadratic question, and I am sure solving this will help you great deal in solving some of the similar problems which are asked in board exam concerning quadratic equations. Let's see the third question now. The product of digits of a two-digit number is 18. When 63 is subtracted from the number, the digits interchange the places. You have to find the two-digit number. So two-digit number questions are very common both in the chapter of linear equations in two variables and in the chapter of quadratic equations. So you need to be careful not to mix the two, and you should be aware when it is a question of linear equation and when it is a question of quadratic equation. Just remember, whenever product of digits is given, then it is a question of quadratic equations. We will see how. Now, whenever you have to assume a two-digit number, then let the two-digit number be 10x plus y. Now, this is the way we assume the two-digit number, in which the digits are x and y, and we have written this 10 here because x is in the tens place. So this is the expanded notation of the two-digit number. That is why we have written 10. But the digits are x and y. So the product of digits is 18. So x into y is 18. This equation will be used to eliminate one variable. This will give us x is equal to 18 upon y. So you can call this equation number 1. We will be using this later. Now, what about the second equation? When 63 is subtracted from the number. So number is 10x plus y. So when 63 is subtracted from this, what happens? The digits interchange places. That means x and y interchange with each other. So this gives 10y plus x. So now you can bring the like terms to one side. 10x minus x is 9x. Y minus 10y is minus 9y, and 63 moves to that side. Now you see 9 is the common factor. You can cut that off. So x minus y equal to 7. Now this is the second equation. Now put the value of x 18 upon y. Here you will get a quadratic equation. So here x is 18 upon y. So just substitute 18 upon y. Minus y equal to 7. This is from 1. And take LCM. Y is LCM. So 18 minus y square equal to 7. Cross multiply 18 minus y square equal to 7y. And here we have the quadratic equation y square plus 7y minus 18 equal to 0. Now this is how we frame the quadratic equation. So what are the middle term split factors of this equation? You should know very quickly what will be the factors of these two. This is 9 and 2, because 9 minus 2 is 7 and 9 into 2 is 18. So let's split the middle term. Y square plus 9y minus 2y minus 18 equal to 0. So take common, y into y plus 9 minus 2 into y plus 9 equal to 0, giving you y plus 9 as the first factor and y minus 2 as the second factor. And therefore y comes out to be minus 9 and y comes out to be 2. So this is to be rejected because digits are never negative. So y comes out to be 2, and put the value of y in equation number 1. You get x is equal to 18 upon y. So 18 upon 2, which is 9. And once you have the values of x and y, finding the two-digit number is just one step away. Therefore, the number is 10x plus y. So 10 into 9 plus 2, that is 92. So the answer for the question is 92. This is how you solve problems based on two-digit numbers. And finally, we have one more question. This is a simple question of numbers. the sum of two numbers, it can be any number, maybe a two-digit number or a single-digit number, is 15. So the sum of two numbers is given. So whenever the sum is given, then this is a question of one variable only. So let first number equal to x. Therefore, second number, whenever the sum is there 15, so 15 minus x will be the second number. And now the equation will be framed from the second statement. What is the second statement? Sum of their reciprocals is 3 by 10. So take the reciprocal 1 by x and 1 by 15 minus x. The sum of them, these two reciprocals, is 3 by 10. And here you have the equation which you need to solve. So take LCM, the two factors x and 15 minus x both will come in the denominator. And 1 into 15 minus x is 15 minus x plus 1 into x is x equal to 3 upon 10. So x cancels out, thereby giving you, so okay, 3 into x, 15 minus x and 15 into 10. Here you can see that this 3 is also cancelling out, thereby giving you 15x minus x square equal to 50. And here you have the quadratic equation x square minus 15x plus 50 equal to 0. So just make the factors very simple, 10 and 5. So x square minus 5x minus 10x plus 50 equal to 0. So x into x minus 5 minus 10 into x minus 5 equal to 0, giving you two factors, x minus 10 and x minus 5. Now if you put them separately equal to 0, so x will come out to be 10 from here and x will come out to be 5 from here. So if x is 10, so first number is 10 and here first number is 5. So what about the second number? Second number was 15 minus x, so 15 minus 10, 5. And from here, second number 15 minus x, 15 minus 5, 10. So in both cases, the numbers are 10 and 5 or 5 and 10. So the numbers are 5 and 10. So this is the answer for the question. The first question which I am taking up is a train track covers a distance of 90 kilometers. So we are given the distance 90 kilometers at a uniform speed. Now what we are doing here in this question is we are increasing the speed by 15 km per hour. So if speed of any vehicle is increased, then obviously it will take less time to cover the same distance. So it takes 30 minutes less to cover those 90 kilometers. What happens? The train was traveling at a particular speed and covering these 90 kilometers in a particular time. So once we increase the speed by 15 km per hour, the time reduces by 30 minutes. We need to find the original speed of the train. Likewise, in the second question which I am going to take up is similar to this one. Only difference is that here the speed is reduced by a particular amount, that is 10 km per hour. Obviously, when you reduce the speed, time will be more. So time taken is increasing by 24 minutes here. So you need to again find the original speed of the vehicle. So let's see how these questions are solved. See here, distance is 90 kilometers and you need to find the original speed. So you need to assume that let original speed of train be x kilometers per hour. And in these questions, you always use the formula for time, which is distance upon speed. Now, distance is given here as 90 kilometers and speed is given as x. So this is the original time. Now what happens? Okay, I'll call this time as t1. This is the original time taken. Now when speed becomes, now original speed was x, now the speed is increasing by 15 km per hour. So x plus 15 kmph. Now this is the new speed. So that implies new time t2 will be distance is same 90 upon speed is x plus 15 now. Now this is the second time taken with the new speed. And the difference between these two times. Okay, first thing we should realize is that this time is more and this time is less. Why? Because here speed is increased, so time is reduced. So difference between these two times T1 and T2 is given in the question as 30 minutes, which is 30 upon 60, that is 1 by 2 hours. Now this concept will be used to frame the quadratic equation, and then once we get to the quadratic equation, we will solve it using the method of splitting the middle term and then get to the answer very easily. Now T1 minus T2 is half, so let's frame the equation. T1 is 90 upon x minus T2 is 90 upon x plus 15 is equal to 1 by 2. Just take the LCM. I've already told you all these questions in equations reducible to quadratic form, how to solve these questions. So 90 times, since 90 is common, so 1 into x plus 15 is x plus 15 minus 90 is common, so x is equal to 1 by 2. So here x gets cancelled and we have, let's cross multiply this, x square plus 15x into 1, that is x square plus 15x, and on the other side you have 90 into 15 into 2, 30, which is 2700. So we have a quadratic equation now, x square plus 15x minus 2700 equal to 0. Now this is how you frame the quadratic equation for these type of questions. Let's do it for this question also, then we will solve the quadratic equation and find the answer. Now in this case, distance is given as 120 kilometers and you have to assume, so let original speed is equal to x kilometer per hour. Again, you use the formula time is distance by speed. So you get time T1 as distance is 120 and speed is x. Now this is the value of T1. Now what happens in this question when speed is, now it is reduced by 10. So x minus 10 kmph. Then time T2 is, distance is same 120 but the speed is x minus 10 now, and this is T2. Now again you need to find out which of the two, T1 or T2, is greater. See here the speed is reduced, and whenever speed is reduced, time increases. So this time is more than this time. So we have T2 minus T1 as given in the question 24 minutes. So 24 by 60, you can cut this off by 12, so 2 by 5. So T2 minus T1 is 2 by 5. This will be used to frame the equation now. T2 is 120 upon x minus 10 minus T1 is 120 upon x is equal to 2 upon 5. Now you can cancel one more common factor here, 2. So this will be 60, thereby giving you equation 60 upon x minus 10 minus 60 upon x is equal to 1 upon 5. Now just take the LCM again, just like here, x and x minus 10 both will come in the denominator, and in the numerator we will have 60 common. So x minus x plus 10 is equal to 1 upon 5. So x gets cancelled, and if you cross multiply this, x square minus 10x will be equal to 5 into, this is 600. So 600 into 5, 3000. And here we have the quadratic equation x square minus 10x minus 3000 equal to 0. So this is how we frame the quadratic equations for these type of questions. Now let us try and solve these questions. For this, the factors are very obvious. 60 and 50, difference of 10, 60 into 50, product is 3000. So x square minus 60 plus 50 minus 3000 equal to 0. So just take common. This is traditional method of solving the quadratic equation. So either x minus 60 or x plus 50, giving you x equal to 60 and x equal to minus 50, and speed cannot be negative, so this is rejected, thereby giving you the final answer. Therefore, original speed is 60 km per hour. So this is the answer of the first question. In the other question here, we have the quadratic equation x square plus 15x minus 2700. So we need to have a difference of 15. So let us try and find out which two factors have a difference of 15 between them, and the product should be 2700. Now, difference of 15 means you start writing from say 40 and 25. 40 to 25 is 1000. So increase it, 45 and 30, not still 2700. So like this you need to find out the factors for middle term splitting. Move up to 60 and 55. This is 16 to 50 is more, so we need to reduce it. So 55 and 40. Okay, 55 and 40 is slightly lesser. So now let us try and find the factors of this. So we find that the factors are 60 and 45. Now 45 into 6 is 270 and one more 0, so 2700. So let's split the middle term. X square plus 60 minus 45 minus 2700 equal to 0, and then the traditional method applies, taking common. So I am doing it very quickly just to save time. So you have two factors, x minus 45 and x plus 60, thereby giving you x equal to 45 and x equal to minus 60, and obviously speed cannot be negative, so therefore this is rejected, giving you the answer. Original speed is 45 km per hour. So this is the way you solve these type of questions when it comes in the exam. All the steps are done neatly. You can follow these steps. And now let us see two more questions based on speed. The third problem here relates to motion of boats, and similar question is written here. This is question number 4. You have to find the speed of stream in this question of speed of boats. A boat whose speed is 24 km per hour in still water. So whenever the water is not flowing, the original speed of that boat is called speed in still water. So speed of boat in still water is given in the question, and it is 24 km per hour. Apart from this speed, we have another speed, the speed with which the stream is flowing, that is the river is flowing. We have to find that speed. So you have to assume that speed of stream is x kilometer per hour. So once you know these two speeds, we can calculate the speed upstreams, which is the difference of these two, 24 minus x, and the speed downstreams, which is the sum of these two, that is 24 plus x. Remember, speed of boat in still water comes first and speed of stream comes later. Now these two speeds will be used for finding the required thing in the question, and the distance given here is 32 kilometers. Distance is 32 kilometers. So again we need to use the concept of the formula for time. Time is distance upon speed. So I'll be using this formula. Time is distance upon speed. I'll write the similar data for this question also. See, speed of boat in still water is 15 km per hour. So I'll write the same statement. Speed of boat in still water is 15 km per hour. Again, you have to assume that the speed of stream is x kilometer per hour, and from these two you can find the speed upstreams, which will be the difference of the two, and the speed downstreams, which will be the sum of speed of water and the speed of stream. Now these two will be used in the question. Distance given here is 30 kilometer, and we use the formula for time, distance upon speed. So similar questions, similar data. How do we formulate the equation now? See, here we are given that it goes 32 kilometer upstream. So the time taken to go upstream will be more because it is against the flow of water. Whereas when it returns, it will come along with the flow of water. That is why that time will be lesser. So how much lesser? The question mentions here that the time taken while going upstream is 1 hour more than while returning downstreams. So the difference of the times is 1 hour. Now time is distance upon speed. Distance is 32 upon speed upstreams is 24 minus x. Now this is the time taken to go 32 kilometer upstream, and this is the time taken to go 32 kilometer downstreams. Obviously upstream time has to be more, so this time I have written first and this time I have written later, and the difference between these two times is 1 hour, which is mentioned in the question. So the equation is formulated now, and all you need after this is to just solve by taking LCM. So let's see how this solution can be done. In the LCM, we will have both the factors 24 minus x and 24 plus x. In the numerator, we have 32 common, and this 24 plus x will come here, minus 24 minus x will come here and change sign, equal to 1. So here 24 gets cancelled. Here we have 32 into 2x, which is 64x, upon 24 into 24, 576, minus x square. I have used the identity a minus b, a plus b, equal to 1. So if you cross multiply this, you will get 64x equal to 576 minus x square, and you get the quadratic equation x square plus 64x minus 576 equal to 0. Now this is what is the quadratic equation which was intended to be framed, so that we can solve this and get to the answer. Now we have to solve this equation by splitting the middle term. I will leave the question here. First I will get to the quadratic equation of the other question also. So in this question we have the distance as 30 kilometers, and the boat is going upstream and then returning back, and we are given the total time. The times are compared in this question, but in this question total time is given. So we, in place of subtraction, we need to add here. That is the difference between these two questions. So 30 kilometer upstreams means 30 upon upstream speed is 15 minus x, and 30 kilometer downstream 15 plus x. The sum of these two times is given as 4 hour 30 minutes or 4.5 hours, that is 9 by 2 hours. Now you can cancel this common factor 3 along the numerators, thereby getting 15 minus x and 15 plus x as the LCM, and in the numerator we have this 10 common, so 15 plus x plus 15 minus x equal to 3 upon 2. So x gets cancelled, and if you simplify this, this is 15 into 10, which is 150. Okay, this is 15 plus 15, 30. 30 into 10 is 300 upon a minus b, a plus b, 225 minus x square, 3 upon 2. Again 3 gets cancelled by 300. 100 times, and you can cross multiply this now. You will get 200 is equal to 225 minus x square, and now we can simplify this. X square equal to 225 minus 200, or x square equal to 25, giving us the value of x as 5. Therefore, what was x? X was the speed of stream. So we have found out the speed of stream as 5 kilometer per hour. Now this is the answer of the second question. Now if you solve this equation, the middle term split of this equation will be 64, and you need the product as minus 576. So 8 means 72 and 8. So plus 72 minus 8 minus 576 equal to 0. So I'll quickly take the common factor x, x plus 72 minus 8, x plus 72 equal to 0, giving you x minus 8 and x plus 72 as two factors of this equation, and x equal to 8 and x equal to minus 72. Negative 72 cannot be the speed, so it gets rejected, thereby giving you the answer speed of stream is 8 kilometer per